Hello everyone. This is another National 5 trigonometry video. What we're going to do, let's take a wee look at the learning outcomes for the unit. So the previous video was all about the first bullet point there, finding the area of a triangle. And hopefully you managed to complete the little extension video as well on working backwards. This video is going to take a wee look at the second bullet point here. Um, I can calculate the length of a side of a triangle using the sine rule. So let's have a wee look at what the sine rule is. So I've got a definition here for you. There is a proof for it, and I didn't really think it would be appropriate. And I wouldn't normally go through the whole proof in class with people unless some people really wanted to see it. So what I'm going to do is I'm going to give you the definition of the sine rule here, but point you in the direction of the proof for it, which is in your textbook. It is in page 2, it is an example on page 203, right? So if you were keen and you were interested, go and have a little look at the proof. Don't worry too much if you don't kind of fully understand it. It's not examined, you don't have to know the proof as part of the National 5 course, but if you're interested, it might give you a little bit of a background. What I do suggest you do, because I know a lot of you like to make notes and things like that, I do suggest you pause the video and take a note of all of this information, right? So that you've got a note of what the sine rule is. Um, so pause the video just now, take a little note of that. Now, what we're going to do, I'll just sort of take you through a little bit of information here about what the sine rule is. So basically in trigonometry, the sine rule is an equation relating the sides of any triangle to the sines of its angles. Okay, so what the sine rule is made up of is three ratios, right? A over sine A, B over sine B, C over sine C. And what that says is that if you take the length of side A and divide it by the sine of angle A, you would come up with a value. And that value would be the same if you did it for B over sine of B, and if you did it for the length of C divided by the sine of C. So it's quite a useful little property. It says the ratios of the side and the sine of its angle is equal for all three sides of the triangle. Okay, so we can use that rule to help us calculate the size of missing sides and angles in non-right angled triangles. And what we're going to do today is just concentrate on finding a side. So let's have a little look at an example here. So we'll take a bit of time over this. I'll go through all the steps very, very carefully with you. And the very first thing that I would get you to do in any case like this is write out the sine rule. Let's have a look at the question. In the following triangle, calculate the value of the missing side labelled x, this one here, and give your answer to two decimal places. Well, that's fine. Okay, we can do that. Notice though that this triangle isn't labelled up. And I would suggest when you are using the sine rule that you do label up the triangle yourself. And it doesn't matter how you label it up, just label the three sides A, B and C. It doesn't matter which one's A, which one's B, which one's C. It really doesn't matter. Just label them up A, B and C. A, B and C. And what that does is it gives you definitions for the triangle. Right, well that side of 12 centimetres, that is side A. The side we're trying to find is side B, and side C is over here, but we'll probably not need that. Now, let's write out the sine rule. That's what I would always start off with first. Okay, so we're going to write out the sine rule. Okay, so for this triangle, the sine rule is A over sine A equals B over sine B equals C over sine C. Right? Now, in a similar way to which you used SOHCAHTOA, what you would do now is tick off the sides and angles that you know. And at the same time, I would also circle the side or angle you're trying to find. Okay, so what have we got then? Well, we've got side A of 12 centimetres, and we've got the angle at A of 50 degrees, so that means I know what the sine of A is. I'm trying to calculate side B, so I'm going to circle that, and I know its angle at B. I know that's 87 degrees, so I now know sine B. I don't have any information relating to angle C or side C, so I'm just going to leave them blank and ignore them. And what you're looking for is a pair of ratios, right? So let's try that out in full. What you're looking for is to choose a pair of ratios where you know 3 out of the 4 pieces of information. Right, and that's important because if you choose a pair of ratios where you've only got 2 out of the 4 pieces of information or 1 out of the 4 pieces of information, then you're never going to be able to solve it. You need to only have 1 piece of information missing, otherwise you can't solve it. So choose a pair of ratios where you know 3 out of the 4 pieces of information. So you don't have to use all 3 ratios, you would just use you would just use 2 out of the 3 ratios. And it's pretty obvious here that we're going to ignore C over sine C and go for this as our pair of ratios. And what we mean by knowing 3 out of the 4 pieces of information, well, there's 2 numbers in each ratio, one on the top, one on the bottom, and I know both of them in A over sine A. I know one of them in B over sine B, so that means that I know 3 out of the 4 pieces of information. So that means I can solve this for B. So choose the pair of ratios, and what I would do is just write that out again. A over sine A equals B over sine B. Right, so we say use A over sine A and equal to B over sine B. Now, what we're going to do is substitute in our information. So this is 12 over sine 50 for A over sine A, 12 over sine 50. Right, and then B we don't know, over sine, and if you look at it again, sine B is 87 degrees. Yeah, so let's calm that down. So that's sine 87. Now, here comes the piece of algebra that helps you then solve this, okay? If I want to just find out what B is currently being divided by sine 87. So to unpick that, as if I'm changing the subject to the formula sort of thing, then what we're going to do is multiply the opposite side by sine 87. So in other words, we're going to multiply through by sine 87. Okay, multiply both sides by sine 87. Okay, left myself much space there. So multiply by sine 87 both sides. And what that does is it gives you, on the top here, it gives you 12 times sine of 87 divided by sine of 50 equal to B. Okay, because times it by sine 87 and dividing by sine 87 at the same time just gives you 1, so we're just left with B there, and that's B. Now what we'll do is we'll run this through the calculator now. Now when you put it through the calculator, guys, I'm going to give you a little tip here. Use the fraction button, right? Now most of you tend to use Casio calculators and the fraction button looks like that. Now when you have it on your display, so if I just draw out a display here, when you have it on the display, What you might have is on the top of your fraction, you might have 12 times sine of 87 divided by sine of 50. Okay. Now, if you're using the fraction button, what you will need to do is close any of these angle brackets. If you don't close these angle brackets, it will come up saying math error, and you won't be able to get the answer. That tends to be the common issue we get when people are using their calculators to do this for the first time. If you're using the fraction button, you must close off all the brackets, otherwise the calculator just gets a bit confuddled and spits out an error at you. So if you do it in the calculator properly like that, then the answer that you are looking for is 146 centimeters. Okay, right. So quick recap then, right? Write out the sine rule. If your triangle's not labelled, label it up yourself. Okay, write out the sine rule. Tick off the sides and angles that you know, and circle the side or angle that you're trying to find. Choose a pair of ratios where you know 3 of the 4 pieces of information. And then once you've got that, write out your sine rule, substitute in the information, and perform your piece of algebra, right? And you'll find that when you're finding the side, that step is pretty much the same in every case. You're going to look at what's underneath the trig term that's underneath the side you're trying to find, and you're going to multiply the other side by it. And be careful, be very careful with your calculator display. Make sure you are closing off these brackets. Okay, it's particularly that one that tends to get forgotten about. Okay, now let's do one more example. Okay, and this is an interesting question. It's going to cover a couple of different aspects here. So what we've got is calculate the size of the shortest side in this triangle. Right, well, how do we tell what the shortest side is? And I suspect some of you will remember how to do that. You'll remember the little key fact about identifying the shortest or indeed the longest side in a triangle. If you don't, then it's really, really easy. All you need to do to identify the shortest side is know that the shortest side is the one that sits opposite the shortest angle. Okay? Sorry, opposite the smallest angle. Okay? So opposite the smallest angle, well, the smallest angle here would be 18 degrees, right? Smaller than 25 degrees, and it's clearly going to be smaller than this obtuse angle up here. So we're pretty safe that 18 degrees is the smallest angle. And so therefore, what that means is the side opposite it is going to be the smallest side. Okay. Even although it might not look it in the diagram, okay, I've kind of deliberately gone for, I know that side PQ looks a little bit longer than side QR. That's a little bit deliberate because you need to look at the maths, not necessarily look at the diagram. The diagram may put you off slightly. You might think, well, that side just looks shorter than the other side, but you have to be, definite here. The smallest side is opposite the smallest angle. And likewise, if the question was flipped on its head and we wanted the size of the longest side, well, the longest side would be the one opposite the biggest angle, and you can see in this triangle that should be 25 meters as the longest side because it's opposite what will clearly be the biggest angle, which is the angle at Q. Okay, so I suppose as an error checking thing, then we are certainly expecting side PQ or side R as it is, to be smaller than 25 meters. If it was bigger than 25 meters, something's going wrong. So now we've established that, what we are going to do is write out our sine rule. That was the first step. Now this triangle's been labelled up for us. It's been labelled up as PQ and R, so that's what we're going to use so we don't get confused. So this will be P over sine P equal to Q over sine Q equal to R over sine R. Right? Now, I'm going to start off by circling what I've to find. I've to find side R here. That's Q and that's P. So I have to find side R. and I know the angle at r, so that's handy, right? So r over sine r, that's certainly one ratio that I'm going to use. Now, what do I know about the other information? Well, I've got side q here, so I'm going to tick that off. I don't know the angle at q, but I know the angle at p, so that. Now, this scenario is quite common and sort of would pose you a problem. Remember that the last example, what I said was choose a pair of ratios where you know three of the four pieces of information. Now, if I went for q over sine q equal to r over sine r, right? So if I went for that ratio and that ratio, well, I only know two out of the four pieces of information because I don't know the angle at q, right? And if I chose r over sine r and p over sine p, well, again, I don't know the length of side p, I only know the angle at p. So again, I would only know two out of the four pieces of information. So this poses a little problem. And there's a fairly easy way around it because ideally, if I knew what the angle at q was, all my problems would be solved because I would then be able to use this pair of ratios. Now, hopefully, if you're looking at the triangle by now, for as long as I've sort of rambled on about that, you may have noticed that in this triangle I know two out of the three angles. And if I know two out of the three angles, I can always work out the third angle, no trigonometry necessary. So what I'm going to do is work out angle PQR. And I'm going to say angle PQR is going to be 180, take away 25, take away 18. And that gives you 137 degrees. Okay, so now I know this angle. That means I can tick sine q off, and I've now got a complete pair of ratios where I know three of the four pieces of information. Brilliant. So we're going to say, let's use q over sine q equal to r over sine r. Excellent. Substitute in our information. So q is 25 over sine q, so sine 137, equal to r, which is what we're trying to find, over sine of 18. Right. Now you remember in the last example, what we did, we used our little piece of algebra to help us rearrange this. So r is being divided by sine 18 there, so we're going to multiply by sine 18 to unpick that, and we must do that to the other side of the equation as well. So times sine 18, and we get 25. Oh, what am I writing? There we go. I get 25 times sine 18 divided by sine 137 equal to r. Punch that through the calculator. Remember to close off any brackets so you'll run into math errors. And r is 11.3 meters. Okay, which is useful because 11.3 meters is less than the 25 meters, so we know we've not gone off track. And that's the shortest side of the triangle. Okay, so quick recap again, write out the sine rule. If you need to label your triangle, label it, okay? Don't try and work with it unlabeled because you know how are you going to be able to tick things off otherwise. If you know two of the angles, then you can always work out the third. You never know, you might need it. Choose a pair of ratios out of the three where you know three of the four pieces of information. Sub in your values and use the algebra trick of multiplying by the denominator of the missing side. Okay, so like in this case, multiply by sine 18 both sides and run that through the calculator. Remember to close any brackets and you'll come up with a correct answer. Okay, so there are some questions that we'll get to try now. Okay, and what I'm going to do is direct you towards exercise 18.2, and I'm going to get to do questions 2 through to 7, And as an extension task, right, I expect everybody to get through question 2 to 7. As an extension task, you should try question 8, 9, and 10. 10 in particular is a good one if you can remember your bearings knowledge from way back in S2. If you can't, don't worry about it too much. We're going to do a whole lesson on doing trigonometry involving bearings away at the end of the unit. But they're good ones to try just now, okay? So thanks very much, everyone. The next video I'll post is going to be looking at how we would use the sine rule to find an angle, given that you would now be able to find the side. All right. Thank you very much.